Hey, what's up? Welcome to this new video. This one is paper 1 of May-June 2004. Now with that being said, of course, let's move on to the question number 1. So here we have a geometric progression has first term, so we know first term is defined by a. A is equal to 64 and the sum to infinity is equal to this. So we know sum to infinity is given to you by 256. Great, so these are the given information. Now part 1. Find the common ratio. We know this is the value of r. How can we find this? We have to use this information. Now, the formula we know for the sum to infinity is equal to what? A over 1 minus r is going to equal to 256. Now let's try to replace and solve for the value of r. A, we know it is the value of 64 over 1 minus r is equal to 256. Now we can just cross multiply to see what happens. So send this over here, you will have 64 is equal to 256 times 1 minus r. And then we can make this become subject. So 1 minus r will be what? Will be 64 divided by 256. Exactly. Now r will be 1 minus 64 over 256. So let's see what does that give you. That will be equal to 3 over 4. That is your value of r, and this is equal to the common ratio that we were trying to find in part 1. Okay, so now let's move on to part 2 of the question. We have to find the sum of the first 10 terms. So sum of the first 10 terms, so when n or t, the number of terms is equal to 10, we have to find the sum. So again, this is something we are given on your list of formula that we kind of have to know. So we don't have to know, we don't have to memorize, but let's write this down. Sum of the first n term is equal to what? It is equal to a 1 minus r power n over 1 minus r. So let's replace and see what happens. So here you have a is given to you by 64. 1 is 1 minus r is equal to 3 over 4 power 10 over the value of 1 minus 3 over 4. Let's see what do we have. So 1 minus 0.75 power 10 times 64 divided by 1 minus 3/4, and that should give you what? 2415837. Now correct your 3 as self, obviously that will be 242 as the sum of the first 10 terms. Okay, yep, that's it. And that will be a question in relation to series, and this one was specifically geometric progression. So now we have to evaluate this integral. So this one is actually pretty easy. Let me do something here that we can actually solve this pretty easily. So here what do we have? We have a square root of 3x plus 1. Now I understand that we can rewrite this as 3x plus 1 power half. Right, now from this you will have what? Integration of 1, 0. You will have 3x plus 1 power half with respect to dx. Now step by step, the first thing you will have to do is to increase the power by 1. You will have 3 over 2. Then divide by 3 over 2. Then multiply by dx, so the value inside that will be 3. And obviously, here we don't have to write plus c because we have limits. So let's not write plus c. No need to do that. And let's simplify this. That will be what? That will be 2 here. 3x plus 1. 3 over 2. 9, and the limits is 1, 0. Now step by step, I can take out these 2. 2 over 9 will be outside, and the inside I can solve. So first I will have 1. That will be 3 times 1 plus 1. That should be 4. 3 over 2. And minus, here we have 0. That should be 1, 3 over 2. So let's see what do we have. So 4 power 1.5. That will be 8. 8 minus 1. That will be 7. So your answer will be 2 over 9 times 7. That should be 14 over 9. Okay, and that will be this question. So part 1, we have what? We have show that the equation, this, is equal to this, can be written in a quadratic equation in tan x. Okay, so let's see how can we do this. So step by step, here we have sine square theta plus 3 sine theta cos theta is equal to 4 cos square theta. Now the first thing we realize that what is tan x? Tan theta is equal to sine theta over cos theta. So we realize that to obtain tan theta, we kind of have to divide by cos theta at some point. So in this case, since we have square, let me try to divide by cos square theta. Let's see what happens. So here you will have sine square theta over cos square theta, that will be tan square theta. Here you will have this over this will be 3 cot. So here we have, cos is going to go away, so it's going to be sine over, it's tan, not cot, tan theta. So let me re-explain, sorry for confusing you guys. So here you will have 3 sine theta over cos theta divided by cos square theta. So this will cancel out with this. So you will have 3 sine theta over cos theta, which is simply 3 tan theta. Okay, and then finally this will be just 1, which is 4, right? So rearrange, you will have tan square plus 3 tan, and then minus 4, that will be 0. And this is shown as required for a quadratic equation. Here we have square, here we have linear, and then minus constant for the quadratic equation. For example, now to move on, I can do something. Let x equal to tan theta. Let's see what happens. Again, this is just to help you. You will see it become x squared plus 3x minus 4. Okay, now we can solve this pretty easily. You can do by factorization, or you can use your formula to do that. So here let's try. We can try factorization. Here we have x squared, it is x times x, and 4 is 4 times 1. We need to have plus 3, I have to have plus 4 minus 1. So x will be minus 4, x will be the value of 1. So here we have two values to look at for. Now again, we're not trying to find x, we're trying to find theta. So x, we know it is tan theta is equal to minus 4, and tan theta is equal to 1. Now for this one, we understand that this is negative, so you will have to be, well, when tan is negative, it will be in your second quadrant and your fourth quadrant. So let's call this will be 360 minus the, let's call this x, and that will be 180 plus x, for example, right? And now again, the angle we're trying to find is only between the first and second quadrant, so we don't need this one. Okay, so we need only this one. Now again, because it is negative, I will go with this way. I will first try to find x. Now again, x is not your answer, it is just to help you find theta. So that will be tan inverse of the positive value of 4 to find x. Now x is not your answer again. Tan inverse of 4, that will be, so we have to use degrees here, that should be 75.96, which is 76.0. Now to find theta, we have to look at the quadrant. Here we have 180 minus, this is minus x, that will be 180 minus 76. That will be 104 as your answer for this one. Now for this one, it's pretty easy. We understand that when tan is positive, it will be in your first quadrant and in your third quadrant. So here, because it is positive, we can find the value directly. That will be 180 plus theta. So theta will be simply tan inverse of 1. That will be 45 degrees. And also we have 180 plus 45. That will be 225 degrees. So there we go. Theta will be 45 degrees and 104 degrees. This one will be outside of the domain that we need it to be, so it will not be taken as the final answer. And this is that for this question in regards to trigonometry. So here we have to find the coefficient of x cubed. Now we understand that the coefficient is simply the value in front of the x cubed. Okay, so we have to find a, for example, in this case. So let's do this. Now for this one, how would you find this? Because normally we know how will we expand this function or expression. So it is a binomial expansion. Again, this formula is given to you as well. We have to know. Usually we will do is the power 6 will take 6, combination something, we have to choose. And the first term is 1 here. And then here we have plus 2x. Now, we know that this, let's call this n here, will match with this one. And this will be 6 minus n. So what value we have to choose for n to get x power 3? So we realize that we'll have to choose n as 3 so that we can get x power 3 in this expansion. So 6 choose 3, that will be what? 20 times 1 times 8x cubed. Now 20 times 8, that will be 160 x cubed, but your answer will be only 160 because we're looking for the coefficient of x cubed. So 160 will be your answer. Now for part 2, we have to find this, right? So one by one. So we do realize that this is actually, how do we expand this expression? It is simply, so step by step, we take 1 first. So that will be 1 multiplied by 1 plus 2x power 6. And here we have minus 3x, 1 plus 2x power 6. But again, the same thing here, we are only interested in the coefficient of x power 3. That's the only thing we care about in this expansion, so we have to try to get that term. Now here we have 1. Obviously 1 have to multiply by something in x cubed. So here we know it is 160 x cubed. But here we don't know, it is 3x. We have to multiply by something in x squared so we can have x cubed at the end. So there will be 6, choose 2. That will be 1 and 2x, and here we have to have 2. 6 minus 2, it is 4. So 6 choose 2, that will be 15. That will be 1, that will be 4x squared. So here we have what? 160 x cubed minus 3 times 15 times 4, that should be 180 x cubed. So you will have 160 minus 180, that will be minus 20 x cubed. So your answer will be minus 20 for the coefficient of x cubed. And that will be this question in regards to series or binomial expansion. So here we have in the diagram, OCD is an isosceles triangle. So OCD, okay, means that this side and this side are the same, or this angle and this angle are the same. That's what it means. Now with OC equal to OD equal to 10, okay, as we can see here, 10 and 10, okay. Now the angle COD is 0.8, so this is 0.8, okay. The points A and B on on OC and OD respectively are joined by an arc of a circle center O and radius 6. Okay, great. So simply, these are the information we have on this diagram. Now part 1, we have to find the area of the shaded region. So by observation, to find this area, we must first find the area of the whole thing. So number 1, we have to find the area of triangle OCD. So how would you find that? We can simply use our formula, which is half times sine of the angle in between, which is 0.8, and times the two sides around the angle, that will be 10 times 10. That will be part 1 of the question. 10 times 10 times 0.5 times sine of 0.8. So here we have to use radians. That will be 35.8678. Now let's move on to part 2 of the question. So here we have, again, same part, we have to move on to the next one. So to find only this part, since we have everything now, we have to minus this one. So number 2, we have to minus the sector OAB. So pretty easy again, that will be half r squared, theta is the angle. So let's do that. Half is half, obviously. R squared is 10, so it is 6 squared now. And times theta, which is 0.8. Let's see, what do we get? Half times 6 squared times 0.8. That will be 14.4 as your value for this area. So we have the whole thing we have this. To get this, we take everything, we minus this to get this, if that makes sense, right? I hope so. So number 1 will be 35.8678 minus this one that we don't want to get the one that we want. So 35.8678 minus 14.4, that should be 21.5, and that will be centimeters square. Now let's move on to the next part. So here we have to find the perimeter of the shaded region. So let's see how can we find this. Again, we have to know the perimeter. It means the distance around that object. So by definition, P is going to be equal to AC, which is 4, plus CD, we don't know, plus BD, which is 4 as well, and plus AB that we don't know. So we have to find two unknowns to satisfy this equation to find the value of our perimeter. So first thing first, let's find CD. CD is this one. Now we can see clearly that we have a triangle, right? We have these two sides. We have the angle in between. We're trying to find the third side. We can simply use the cosine rule. So let me write this down. So cosine of the angle is going to be equal to what? Tan square plus tan square minus CD square over the value of 2 times 10 times 10. Okay, so let's simplify and solve for the value of CD. So cos of 0.8 times 2 times 10 times 10, that will be 139.3413. So 10 square plus 10 square, that will be 200 minus CD square. CD square will be what? 200 minus 139.3413, that will be 60.6587. So from here, we can find the value of CD. CD will be square root of that value, that will be 7.79. Okay, so that will be CD as required. And finally, we have to find the value of AB. Pretty easy. AB is the arc length, and we know by definition the length of arc is equal to r times theta, which is the angle. Radius is equal to 6, and the angle is 0.8. That will be what? So let's check. 6 times 0.8, that should be 4.8 as the value. So let's add everything together to find the value of our perimeter. So 4 plus 4 is 8, plus 7.79 plus 4.8, that should be 20.59. Okay, so that will be part 2 of this question in regards to circular measure. The curve y, 9 minus 6 over x, and the line intersect at 2 points. So they meet at 2 points. Again, whenever you see intersecting or intersecting, meets, cuts, we understand we will have to be solving a simultaneous equation. Right. Now part 1, we have to find the points of intersection. So pretty easy. Here we have y, and here we have y. We can substitute into each other. So on one side you will have, so here we have y. We don't know y is also equal to this, so we write 9 minus 6 over x plus x equal to 8. Okay, so to eliminate this value, we have to multiply by x everywhere. You will have 9x minus 6 plus x squared equal to 8x. Okay, simplify. Let's send everything to one side. You will have what? So here we have x squared. Then we have 9 minus 8, that should be plus x, minus 6 is equal to 0. So simplify. That will be x times x. That will be 3 times 2. That should be plus 3 minus 2 for this value of plus 1. So you will have x is equal to minus 3, x is equal to 2. Now finally, y is what? Y will be replaced back in our main equation. You will have 9 minus 6 over minus 3. That should be 27. Right? Sorry, I think it's a mistake. 9 minus 3 over divide by minus 3. That should be 11. Not 27. So if you think logically as well, 6 divided by minus 3 should be minus 2. So 9 minus minus 2 will be 11. Right. Now this one, y will be 9 minus 6 over 2. That should be 9 minus 3. That should be 6. So the passing point will be, first one is minus 3, 11. And then we have 2, 6. So these two are the points of intersection. That is part 1 of your question. Now for part 2, we have to find the equation of the perpendicular bisector of the line joining the 2 points. So pretty easy. So if you think about this, we have these 2 points here. This is the point. Let's call this A and B. So this is A and B. Now we're trying to find the perpendicular bisector, which is the one that passes at the midpoint at 90 degrees, right? So how would you find the equation of this perpendicular bisector? So pretty easy. To find the equation of a straight line, we must first know the gradient of a straight line. So first we have to find the gradient of P. Now to find the gradient of P, we have to find the gradient of AB, for example, right? We can use that. So let's find this. The gradient of AB by definition will be 6 minus 11 over 2 minus minus 3. That should be what? 6 minus 11 divided by 5. That should be minus 1. Okay, so you will have this is equal to minus 1. So by us knowing that whenever we have two lines which are perpendicular to each other, their gradient will multiply to what? So we have to know this concept will be minus 1. So from this we understand that the gradient of the bisector will be 1. Okay, so from here we know the gradient. Now we have to find this passing point. This passing point is the midpoint of AB. So M is equal to, so that will be x1 plus x2, that should be minus 1, then divide by 2. And then here we have 11 plus this, that should be 17 divided by 2. This is my x value, my y value, so we have to use that to find the equation of P. So y minus 17 over 2 over x minus minus half, that should be 1. Let's cross multiply, you will have y minus 17 over 2 is equal to x plus half. Let's multiply everywhere by 2, you will have 2y minus 17 is equal to 2x plus 1. 2y is equal to 2x plus 1 plus 18. So 2y has to be 2x plus the value of, 17 here plus 18. So finally, y could be, we can divide by 2 everywhere, that should be y equal to x plus 9 as your equation of that line P, which is your perpendicular bisector. Now again, by definition, what does it mean? It is a line that passes through the midpoint of the line joining those 2 points. So it's the midpoint, passes through the midpoint, and it is at 90 degrees to the other line. This is by definition of the meaning of this term, perpendicular bisector. Okay, and that will be your question regarding the quadratic equations, or we can call this also the coordinates. I don't think it's geometry, this one. It will be more about quadratics and solving simultaneous equation. The diagram shows part of the graph y equal to 18 over x. So let's label this. This is my graph y equal to 18 over x. And the normal to the curve at the point 63, so here we have the point 63 is the normal to the curve, okay? Now, this normal meets the x-axis at R, right here, okay, great. And the point Q is on the x-axis, okay? And the point S on the curve are such that PQ and SR are on the same direction to the y-axis. So, PQ is this one, and SR, this one, they are vertical lines. Okay, great to know. Now, part 1, we have to find the equation of the normal at P. We have to show that R is the point S. So pretty easy. To find the equation of a straight line, we must first find the gradient of P. Now we understand that because it is a perpendicular line, we will first have to go find the gradient of the tangent, which is also called dy by dx. Now why is this? Let's recall y. Y can be rewritten as 18 x power minus 1, right? Now to find dy by dx, so dy by dx, that will be what? 18 that will be x, have to multiply by -1 first, that will be minus here, then -2, that should be minus 18 over the value of x2. Okay, now what else do we need to do? So we have this, we have to find the gradient, so dy by dx at the value of p is the value of x is equal to 6, as you can see here, right? So what is that will be minus 18 divided by 36, that should be minus half, right? So the gradient of the so this value is equal to the gradient of tangent is minus half. Now we know that MP, or the gradient of the normal, is perpendicular to the tangent. This will lead to gradient of the normal have to be the value of 2. Now since we have the gradient and we have the passing point, we can find the equation pretty easily. Let me continue over here. The passing point was found to be 6, 3. This is the x value and the y value. So y minus its corresponding value over x minus its corresponding value will be equal to the gradient, which is 2. 2 is 2 over 1. Now we just have to cross multiply. You will have y minus 3 is equal to 2x minus 12. So y will be 2x minus 12 plus 3. That will be y is 2x minus the value of 9. Okay, this will be the equation of the normal at p. Now we have to show the value of r, or the point r is given to you by this. Now the point r is on the x-axis. Now we know that on the x-axis, what do we know? The value of y has to be 0. Replace it back in your equation. You will have 0 is 2x minus 9. So 2x will be the value of 9. So x will be the value of 4.5. So we have shown that the point r will be 4.5, which is 4.5 and 0. That will be shown as required as well. That will be part 1 of the question. Now let's move on to part 2 of the question. So we have to show the volume of the solid obtained when the region is rotated through 360 about the x-axis. Now again, we have to know by definition or by memorization, when you rotate around the x-axis, we have to use this formula, which is the integration, and that will be pi y squared with respect to dx. Now what are the limits? As you can see, we have this point and this point. This is 4.5, and the point Q is simply 6, right? This is the x value of the point Q. Because it is directly below P, P has x value 6. If it is exactly below, it will be 6 as well. So the limits will be 6 and 4.5. So let's see what do we get. Now y is equal to this or this. Y squared will be what? 18 squared over x squared. Now what is 18 squared? That will be 324, and then we can bring this up. That will be x power minus 2. Let's replace that. That will be pi. We can take this outside. You will have 324 x power minus 2 with respect to dx. That will be 6 and 4.5. So simplify. 324 pi integration of 6 4.5 x power minus 2. So step by step, first we have to do what? First we have to add 1 to the power. This is just a constant, right? We can leave this outside. We add 1, that will be minus 1, then divide by the same power, and that's it. That will be 6 and 4.5. So you will have, let's see, 324 pi. First one you will have minus 1 over x, x is 6, then minus 1 over 4.5. Let's see what do we get. So minus 1 over 6 plus 1 over 4.5. That will be this. Then multiply by the value of, minus 1 over 6 plus 1 over 4.5. That should be this value. Multiply by 324. That should be 18. 18 pi for the units cube for the volume of the shape. As you can see, the most important part here was knowing when you rotate something about the x-axis, we have to use this formula right here, pi y squared. Now the limits, you can see clearly, we have to find those 2 points. And because they are vertical lines, this one we know it has to be exactly below P. P it is, the value of x is 6, which means Q will also have the value of x as 6. The point Q will be 60. Now we have found this already from part 1. We can use that as your limit as well. And then otherwise, everything else pretty simply, we can just use that, proceed step by step, and then solving to find the volume of the shape. And that will be the question in relation to integration. Now in this question, the diagram shows a glass window consisting of a rectangle of height h, okay, and the width of 2r right here, okay, great, and a radius of r for this semicircle. Now, the perimeter of the window is this. Okay, great. So this is something given to you. You have to use this somewhere, somehow. Part 1, express h in terms of r. So, first thing first, we know that the value of p, the perimeter is 8. So how would you find the perimeter of this shape? By definition, the perimeter is the distance around the object. So let's see, how can we find this? We begin here. That will be this. So 2r plus h over here, and plus this length of this semicircle. Now you must know by now that the circumference of a circle is given to you by 2 pi r, if that makes sense, right? So it means that if you want to find half of the circle, you have to divide by r. That will simply pi r. So pi r, and then equal to 8. Simplify, you will have 2r plus 2h plus pi r is equal to 8. Now h, so you have 2h, that will be 8 minus 2r minus pi r. h will be 8 minus 2r minus pi r divided by 2. Okay, or you can simplify as well. H will be 4 minus r minus pi over 2 r. There you go. That will be h in terms of r. Now for part 2, we have to show the area of the window is given by this. So how would you find the area of the window? There's two parts, obviously. On top we have this 1, which is area of the semicircle, and 2, we have this area of this rectangle. So step by step, number 1, semicircle will be, area of circle is pi r square divided by 2. For area of semicircle, that will be pi, radius is r square, and half is half. So this is part 1. Now for part 2, area of this rectangle. So pretty easy. Rectangle will be length times width, which is equal to 2r times h. That will be 2rh. So let's write this down. Area we have found will be half pi r square, and then plus the value of 2rh. Now we know h was found to be 4 minus r minus pi over 2r. So let me rewrite this down. So you'll have half pi r square plus 2 r times 4 minus r minus pi r over 2r. Now let's see, what do we get? Half pi r square plus 8r minus 2r square minus 1. Here you will have minus, this will be cancelled out. You have pi r square. Now what else? So let's see, what else can we do here? So we have 8r minus 2r square, and here we have plus half pi r square minus pi r square. That should be minus half pi r square. And this is shown as required for question part 2. Now part 3, given that r can vary, we have to find the value of r at which a has a stationary value. So pretty easy. As we know, at the stationary value, we have to have a over dr has to equate to 0. So let's find that. So dA by dr has to be, first thing will be 8 minus, that should be 4r, and then minus pi r. Then equate that to 0. So you will have 4r plus pi r has to be 8. So divide, so we just factorize, you will have 4 plus pi 8, r will have to be 8 divided by 4 plus pi. Let's equate that. You will have 8 divided by 4 plus pi, that should be 1.12, and that will be your value for r. Correct to 3SF. Of course, it is centimeters. Now following up, we have to find the nature of this stationary value. So we have to differentiate one more time. d2a by dr2, that should be 0 minus 4 minus pi. As you can see, that will be negative value. So because it is a negative value, we conclude the stationary value will be a maximum value. So that's your reasoning. Because it is a negative value, it will be a maximum value. And that will be your question in relation to differentiation. Okay, so in this question we have, relative to the point O, the position vectors of A, B, and C are given to you by these as follows. Now, what P and Q are constant that we have in these vectors. Right here we have P and Q. Now part 1, we have to find the unit vector in the direction of AB. So let's first find AB. AB, by definition, that will be OB minus OA. That will be what? OB is 3 minus 1, 3. OA will be 1, 3 minus 1. Let's see, that will be 3 minus 1 is 2. Minus 1 minus 3 will be minus 4. 3 minus minus 1 will be 4 as well. That will be AB. Now we have to find the magnitude of AB. That will be root of 2 squared is 4, plus 4 squared is 16, and 16. That will be 4 plus 16 plus 16. That will be root of 36. And that will be the value of 6. So let's see, the unit vector will be the vector itself, which is 2 minus 4, 3. So 4 over the value of the magnitude will be 6. That should be divided by 2. You will have 1. And you will have the value of minus 2, 2 over the value of 3. So you can write this as follows for the unit vector that we have in the direction of AB. Now, we have to find the value of P for which the angle AOC, so AOC is 90 degrees, so they are at right angle. So we understand that AOC, this will be O, this will be A, this will be C. So the angle here has to be 90. So pretty easy. We will have to use dot product. So in this case, we understand that the vector AO dot product of OC have to give you 0 because the angle here is 90. We understand that cos of 90, that is basically, of course, radians, degrees will be 0. So this will be the thing we have to use or show to solve the question. So here we have what? 1, 3 minus 1 dot of OC, that should be 4 2p. That should be 1 times 4 is 4 plus 6 minus p, that will be 0. 10 minus p will be 0, so p will be the value of 10. That will be part 1 of the question. Now for part 2, the values of q, we have to find the values of q. So we understand from this question we have more than one value of q for which the length of AD is 7. So pretty easy. First, let's find AD. AD is simply OD minus OA. OD is minus 1, 0, q. Minus OA is 1, 3 minus 1. That should be minus 1 minus 1 is minus 2. That should be minus 3. And that should be q plus 1. Now how would you find the length of AD? By definition, that will be root of 2 squared is 4, plus 3 squared will be 9, and then plus q plus 1 squared, that should be the value of 7, which means that should be 7 right here. So we can square both sides. You will have 4 plus 9 plus q plus 1 squared, that should be 49. So q plus 1 squared, that should be 49 minus 9 minus 4, that should be 36. Which means q plus 1 could be plus minus 6. So from this we follow up with what? We follow up on this side. Q plus 1 could be 6 and q minus 1 could be, so plus 1 could be minus 6. So q could be 5 and q could be minus 7. So these are the two possible values for q for this question in relation to vectors. Let's move on to this question. So here the function g and f and g are defined by the following equations. Here we can see this will be a quadratic function, a minimum curve, and this will be a straight line, right? Now this will be x can take any value for those two equations. Part 1, we have to find the set of values for x for which fx is more than 15. So pretty easy. Fx is x squared minus 2x more than 15. Again, that is pretty easy. We have just to rearrange it first. That will be this minus 15 has to be more than 0. So now we have to find the critical values of x. That will be same thing. we just have to equate that to 0. That'll be x times x, 5 times 3, minus 2 will be minus 5 plus 3. X will be 5, x will be minus 3. So here we have those critical values. Now we have to use that to find the range. So by looking at our number line, this is my line 0, this is minus 3, and this is the value of 5. We know the shape of the curve will be, it is positive 1, it will be this shape, right? Now we're trying to find the value more than 0, which is this and this. So which means x have to be less than minus 3, x have to be more than 5. So this will be part 1 of the question. Let's move on to part 2 of the question. So find the range of f and state with reason whether f has an inverse or not. So as you can see here, the shape of f will be something like this. We understand that because the equation is a quadratic equation and the value in front of x squared is 1, so the shape will be something like this. Now the range is the y values of the curve. As you can see, it has a minimum value. Let's find what value is that. So let's see. So we can simply find that because we can just do something here. The stationary value happens when df by dx is equal to 0. So let's find df by dx. That will be 2x minus 2. That will be 0, right? So x will be 1. Now the y value will be replaced in the equation. That will be 1 minus 2. That should be minus 1. So by observation, you can see the curve will be always more than or equal to the value of minus 1. So y more than or equal to minus 1 will be the range of the curve. So that will be part 1 of the question. Now state with reason has an inverse or not. So it does not have an inverse, no inverse, right? Because the reason why it is not a one-to-one function. That's the reason why. Again, you can write this because it is not a one-to-one function. Because if you were to draw a line here, for example, you can see for each line that we draw, we have 2 values that we get, which is not good. For a function to have an inverse, for example here, when I draw a line, I have only 1 value, and because of that, it is called a one-to-one function, and we can only have an inverse for a one-to-one function. So no inverse because not a one-to-one function. That makes sense. Now part 3. So here we have to show the equation has no real roots. So pretty easy. So first let's find g of f of x. That will be g of f of x, right? That will be 2 f of x plus 3. That should be 2 times x squared minus 2x plus 3. That will be 2x squared minus 4x plus 3. Now we have to equate that to 0, obviously, according to the equation. So now we have this. This is my value of a, b, and c. So that will be a is 2, b is minus 4, and c is 3. So let's find what is b squared minus 4ac. b squared is 16 minus 4 times 2 and times 3. That should be what? 16 minus 4 times 2 times 3, that should be minus 8. So since b squared minus 4ac is less than 0, we conclude it has no real roots. That is part 3 of the question. Now for the last one, is sketch on the graph, on the single diagram, the graph of this, of g of x, and making clear the relationship between the graphs. So as always, as you guys must know by now, there's only one kind of relationship between a graph and its inverse. It is simply a reflection in the line y equal to x. Always going to be that case. The sooner you learn this, the better it is. So it's always going to be that thing, the relationship between them. So we can draw this sketch. That'll be this y-axis. This is my x-axis, right? For example, let me draw this graph. This is simply 2x plus 3. So we understand that this is y here. So when x is 0, this will be 3. That will be something over here. and when x is equal to let's say what value? Let's say when y is 0, x will be minus 1.5. Let's say over here. The graph will have a shape something like this. This is my graph, y equal to g of x. Now we know that it will be a reflection in this line, so let's try your best to kind of sketch this line. It's not perfect, but you get the idea. That will be y equal to x. And the inverse curve will be something right here as a reflection to this one. That will be y equal to g inverse of x. As you can see, that was the most important thing to do, is first draw the line, then show this line, and then reflect the other line on the other side. You can always show those points of intersection as well, so you prove exactly, you know what you are doing. Okay, so this will be the question in relation to functions.